Hey, and welcome to this presentation. Today, I'll be introducing Educator's Friend. The focus is on a simple but important idea: how generative AI can support educators in creating learning content more efficiently without compromising quality. Teaching often involves a significant workload, especially when it comes to designing materials and learning activities. At the same time, new tools like generative AI offer possibilities to support this process, while also raising questions about accuracy, reliability, and effective use. In this presentation, I'll walk you through how this approach works, what challenges it addresses, and what we can learn about using AI as a practical support in education. The article starts from a practical problem in higher education. Academic staff face heavy workloads, and teaching, including creating learning content, takes a large share of that work. At the same time, generative artificial intelligence is presented as a possible way to create engaging learning content more efficiently. However, the article also emphasizes important uncertainties, especially factual inaccuracy, reliability problems, and bias. In this context, the study focuses on information security education, where high quality and engaging teaching is especially important. Because the authors found little pedagogically grounded guidance for using LLM-based generative AI to create learning objects, the article formulates two research questions. First, which initial design principles can be derived? And second, to what extent evaluation supports the assumption that such tools help educators create effective, high-quality, and engaging learning content. Before presenting the artifact, the article clarifies two core terms. Design principles are defined as prescriptive statements that indicate how to do something to achieve a goal, including information about the implementer, users, aims, context, mechanisms, and rationale. In this study, they are treated as initial instance-based design principles rather than mature principles. Learning objects are described as interactive web-based tools that support the learning of specific concepts by enhancing or guiding learners' cognitive processes. They are also focused on specific curriculum topics, reusable, and intended to promote learning. The article's learning object is a digital reusable module in an LMS on brute force attacks and password security. The learning object is grounded in computer-supported collaborative learning, or CSCL. The article uses CSCL because it is considered effective for facilitating learning outcomes and is built on the idea that collaborative knowledge construction and problem-solving can be assisted by technology. The authors refer to 7 CSCL affordances, including collaborative tasks, communication, sharing resources, productive processes, co-construction, monitoring and regulation, and building groups and communities. This pedagogical foundation is implemented in 4 elements of the learning object: a text-based motivational introduction, a learning video, quizzes, and collaborative tasks. These elements were guided and moderated by educators and presented in visible sequential order within the LMS. The application domain is a bachelor-level lecture on data privacy and information security at a German state university. To generate textual learning content, the study used ChatGPT Plus based on GPT-4 rather than GPT 3.5 because GPT-4 was considered more accurate, especially for German. Because GPT-4 at that time was trained only on data up to September 2021, the authors added the WebChat GPT browser extension to incorporate current web information. For the video slides, Microsoft PowerPoint was used, including the AI-based designer feature to generate visual slide layouts. For the voiceover, the study used 11 Labs because of its web-based interface, human-sounding multilingual voice, and German voice cloning capabilities. The article then describes the concrete content created for the 4 pedagogical elements. ChatGPT generated the motivational introduction, the voiceover script for the learning video, quizzes, and collaborative tasks. The learning video was based on a 391-word voiceover script, revised and then summarized by ChatGPT into bullet points for 7 PowerPoint slides. 11 Labs generated the voiceover audio, and the finished video was 2 minutes and 54 seconds long. For assessment and practice, ChatGPT generated 24 quizzes across different formats and levels of difficulty. For collaborative work, the authors began with one existing mathematical task and used ChatGPT to generate 3 more complex tasks and explanations. The study also reports an intermediate indication about efficiency. Two educators from different fields estimated that creating a similar learning object without generative AI would take about 180 to 210 minutes. By contrast, the reported AI-supported approach took 130 minutes in total, including preparation and adjustments. At the same time, the article is careful not to overstate this result. It explicitly says that accurate time comparisons remain a task for future research and would require rigorous comparisons across multiple educators and equivalent pedagogical designs. The first design principle follows from the content creation process. The article argues that educators who want to generate learning content for a whole learning object with generative AI should have a thorough understanding of their pedagogical concept. They should know the learning elements, the expected content types, and the task constraints in advance. This is necessary to generate coherent content element by element. For ChatGPT specifically, the article recommends using prompt instructions for each element and keeping one session for one learning object. The reasoning is that without prior pedagogical work, ChatGPT may produce a large amount of content that is incoherent and does not fit the pedagogical storyline, which would also increase revision time. The second design principle is that educators should apply prompt engineering as a general mechanism for getting the desired results from LLM applications, such as ChatGPT. The article derives four facets. First, educators should employ priming and provide specific reference information, such as validated documents or open educational resources, to increase output quality and reduce hallucinations. Second, they should introduce a persona so the model adopts a suitable viewpoint and writing style, for example, an educator persona. Third, they should use self-reflection to improve quality. Fourth, they should write precise prompts, give feedback, and repeat prompts when necessary, including asking for multiple versions for efficiency. The study presents prompt engineering as relevant to learning, engagement, and quality. The third design principle comes from the difficulties the authors encountered. Despite careful prompting, some output still contained false facts, missing information, and outdated content. For example, the motivational introduction initially included false facts about password breaches. The video script needed two important manual corrections, and about 5% of its semantic structure was improved manually. In the quizzes, 2 out of 24 questions were initially incorrect and were discarded. Based on these experiences, the article argues that educators who aim to create high-quality learning content should carefully consider the current limitations of the applied LLM so that they can revise output effectively and efficiently. To evaluate the design principles, the study focused on students' perspectives on the implemented learning object. The evaluation examined three constructs: learning, engagement, and quality. For this purpose, the authors used a slightly adapted version of the LOSS questionnaire. The final questionnaire contained 12 quantitative items on a 5-point Likert scale and 8 qualitative items, tailored to the 4 pedagogical elements with 2 questions per element. The sample consisted of 31 students from the bachelor lecture after one invalid response was removed. Internal reliability was satisfactory for learning with Cronbach's alpha of Dayton 906 and engagement with .73, while quality was lower at .624 and therefore interpreted more cautiously together with the qualitative data. The quantitative results indicate an overall positive evaluation. All three constructs had mean values above 4.0. The median values were 4 out of 5 for learning and engagement and 5 out of 5 for quality. All individual items had medians of at least 4 out of 5, and 3 items reached a median of 5 out of 5. The instruction was easy to follow, the learning object was easy to use, and it was well organized. At the same time, 2 items had somewhat lower mean values, helping students learn a new concept at 3.65 and being motivating at 3.90. The article also notes lower mean values for business information system students, especially for learning and engagement. The qualitative results add detail to the overall picture. The study received 212 qualitative feedback statements, which became 236 coded statements after splitting statements that referred to multiple subcategories. More than 75% and up to 88% were coded as like statements. For learning, students described the video as helpful and valued its metaphorical comparison, while some wanted more new information and detail. Quizzes were seen as supportive for repetition and as offering different levels of difficulty, although some students found them too easy. For engagement, the motivational introduction was described as motivating, enjoyable, and curiosity fostering, while the video was described as enjoyable and lively. For quality, students often describe the introduction as well written and clear, and the video voiceover as comprehensible, though a few students criticized the voice quality or monotony. In the discussion and conclusion, the article argues that the evaluation supports the design principles overall. Students did not report major consistency problems or made up information in the implemented learning object, and feedback was largely positive regarding learning, engagement, and especially quality. This supports the importance of prompt engineering and of building content from clear learning objectives and pedagogy. At the same time, the negative statements show that generative AI should be used cautiously. In particular, AI-generated tasks and quizzes need careful checking for similarity, ambiguity, and wording problems. The article therefore answers the second research question by concluding that the approach was overall perceived as effective, engaging, and high quality, while still requiring careful human revision.